Okay, howdy and welcome back. So we're going to talk about runtime errors and we're going to differentiate from them from logic errors, which also occur at runtime. And hopefully the motivation for that will be clear as we move through this video and the next of this lesson. So runtime errors are going to be errors that are found made during a running found by checks made during a running program. This can be detected by the computer's underlying hardware. It could be an error detected by a library or even an error detected by user code. So runtime error. We'll focus here on the error detected by the computer. Let's say that we're just performing simple division. We have stored in an integer named numerator 1, integer named denominator 0, and we attempt to initialize result with numerator divided by denominator. In this case, the execution of our program will terminate due to this error of attempting to divide by 0. Notice that if we were attempting to do 1.0 divide by 0.0, so floating point division and not integer division, we would not observe this error. We would not see this divide by 0 error characteristic of integer division. Instead, this would essentially go to infinity, is what would happen if we were to output result directly after. So we can see here that the computer hardware can detect different errors, and in the case we showed here was the integer division by 0. In addition to this, we'll see that runtime errors can be detected by code that's been by code defined within a library. For instance, let's say that we have a vector of integer values. My values, it's initialized with 1, 2, and 3. 1, 2, and 3. And that's my values. Let's say we go ahead and begin looping through that vector. And just to illustrate a point, let's say we have an off by one error in our loop conditional. So essentially what's going to happen here is we're going to continue to execute the body of our for statement until I is one more than my value size. The first time we go through this, we're at index 1. Second time we're at index 0, so visiting element 1. At the second iteration, we're visiting the element residing at index 1. At the third iteration, we are visiting the element at index 2. And notice that because we said while I is less than or equal to size, we will attempt to access the element residing at 1 past the last in this vector. And in this case, because we're using the at behavior of our vector, we're going to see that an error will occur, an exception is thrown, and what we would observe in the terminal window is terminated, essentially our program terminated after throwing an instance of standard library out of range. So we'll get into what exceptions are, how they're useful in the next lesson. But right now, just notice that what's written out to standard output in this case would be very informative. It's saying that, okay, well, somewhere you're attempting to index into a vector on its range check. The index you used was 3, and that is greater than the actual size, which is 3. So you're attempting to access an invalid location in that vector. Hence, this exception occurred and your program terminated. So there are also runtime errors detected by user code. So we can find errors through various checks made during a running program. We could easily kind of catch local runtime errors, such as the following using simple conditions. Let's say we're attempting to read in a positive value from standard input, and the user provides a value, say, less than or equal to 0. We could go ahead and catch that error at that point and do something about it. Now, the big question comes, how do we address non-local errors? So let's say we're in a function, we call some other function, and an error occurs here. How do we handle that error? And what we'll see is that with exceptions, we allow essentially the reporting of that error to be separated from the handling, which was not the case in the local runtime error that we just discussed. So we'll see that exceptions are going to be a very, very powerful tool at our disposal.